So this for the normal types. Now, something interesting of Julia is that you can use so-called parametric types, both for abstract types, but also for, like show here, for composite types. And here I'm using, this is the syntax that you use. So you save that you use some name placer for the parameter, and you say that it must be a kind of a number, so a child of a number. And here then you define x and y of this point to be of the same type. So the only here you can have t as the whatever type under a number, but what is important is that when you define like this, x and y are constrained by the kind of being the same type. And notice here that Julia is smart enough to heuristically find the t by itself, the capital T by itself. So here I'm creating a point, and notice here, when I say type of, if I say type of O, well, the parameter is part of the name of the type. So this is a parametric type, and the whole name uniquely identify the type. Only the name identify only the family of the type. And here I call it with two integers. Here I'm calling with two float for x and y. And if I try to use one integer and one float, I will have an error. Now, this is not only for the parametric type. We saw is not only for the structure, but is used also in the functions. And something I want to say is that here is the syntax when you create a function to use the parameters. So here I'm calling I'm creating a outer construction. This is when you have parametric type, you use this syntax for with the parameters also in the outer construction, and then you call it with the different terms. The parametric types are not only composite types, but as I said, abstract type can also be parametric, and this is the syntax. Now, where we saw very early in the course parametric types? Well, if you remember, in the array, so an array here is nothing else than a parametric type with two parameters, where I can say type of and L type to say look the inner types. So you notice here something particular. So this is what we just saw. Is integer 64 is a type, so the parameter itself is a type, like here. But this is not a type, this is a number. And it came out that the parameter that you use in the types or in the function doesn't need to be itself a type, but can be any value also of a bits type. In practical, what is used the integer value. So you can use as parameter or a type or a value of a bits type. What are bits type? Bits type are all kind of types that are made only with primitive types. They are made only with primitive type or with composite type that are themselves made only of primitive or other other bits type. So you can have a hierarchy of a composite type, but at the end, the only fields that must be present are primitive types that cannot be a reference to another type that is not a primitive type. These types can be inferred with their size exactly, and they can be used as a parameter in parametric types. And here you see an example where I'm defining a type, my type, just to be original, where the first EU parameter will be a type and the second one will be a number, an integer. From here you don't see, as you can see, I didn't specify. It is from the usage that I do of it's when I create my object that I'm assigning to these two name keeper, name bindings, a type and an integer. So here I create my integer matrix inside, and he recognizes, because an array take a type and an integer, that this t must be a type and this n must be an integer, and I'm filling with a matrix, and here I'm filling with a vector, and here I'm creating another functions, and where just to show that even for functions you can have parameters that are types or integers, and here I'm calling my function. And if you want to have a look on specific where types are where parameters are not types, you can look on static arrays that define arrays where, differently from the standard array, the size itself, it's an information that is compiled, that it enter into the type itself, the name of the type, so that the compiler, the just-in-time compiler of Julia, is able to make more optimization, because it know the size of the array that remain fixed.